Seems to be a view that Jamstack sites are for static or simple websites only. I'm going to dispel that myth and show you that you can have complex search functionality such as this, where you can search over larger sets of data and bring back larger result sets of information. This is not static, this is coming from a database. Let's go and plug a database into this site and show how we do this. Good morning, good afternoon, or good evening, whenever it is that I find you, and welcome along to the channel. So today we're talking about Jamstack and search functionality. So looking at how we can find data on our website, but potentially over larger data sets than we would want to readily embed in our page. So here's an example of where we've got data that's built into the actual site itself. But what we're talking about here is data that could be thousands of rows, tens of thousands of rows. So thinking about finding blog posts, maybe when you've been blogging for a few years and you've got thousands of blog posts that you've done, or maybe you work for an organization that wants to have a Jamstack site and you've got 1,000 employees, 2,000 employees, something like that, and you want to find a particular employee within your workforce. So how can we do this? We can actually use SQLite, which is a very lightweight database, and we can embed that inside of our Azure Function API. So we're not incurring additional architectural costs or implications around that. Things like cloud relational databases or NoSQL databases, anything like that. We're still sticking with exactly the same architecture that we have for this Jamstack site. We're just leveraging the fact that we can embed a database within our API and ship that with it when we send it up to the cloud. So how can we add a SQLite database into our site? So let's go and have a look at the code and jump over here, and let's go and look inside our API folder. And ahead of time, I've created inside the API an app data folder. And within that, I've got an HR database, SQLite database. And if you want a tutorial on how I created this database and scaffolded the entity framework classes that I've also got embedded here, then let me know in the comments and I'll do that in a future video. So we've got our database and I've scaffolded out the context against that. So we've got inside our database a list of employees. Employees have departments. Departments could be in countries. Employees have jobs. They have job histories where they might have changed, etc., etc. So there's a bunch of data inside of that database basically. And we've got our database context. So the first thing that we need to go and do is add in both Entity Framework Core and the SQLite provider for Entity Framework Core into our API project. So let's go and pull in those two NuGet packages. What I'm also going to do is add in another build step in here that basically says to copy across the SQLite database if it's newer than the one that's already been copied to the output directory. So when we build our API and we create our debug folder that's got, or our release folder that's got our actual compiled code, it's going to copy that app data HRDB across if it's newer than the one that's already there, is all this is saying. So that gets our database into our actual deployment folders when we build our API. So let's just save that and get rid of it for now. Then we can come over to the program CS, and this is just the vanilla program CS at the moment, but we want to go and add in Entity Framework into this, which we can do by overriding the configure services method, and we can set up a context factory for our database context. And we can set the options to say that we want it to use SQLite, and here is where it can find the database in the app data folder relative to our API. And we're also going to set up the logger factory for Entity Framework as well, passing in the iLogger factory. So that sets us up with an entity framework that we can inject into our API at the various points. So let's go and actually do that. Let's come over to the API and we will create a private variable against this class where we'll store the context factory. So that gets us a private variable there. We need to inject that into the constructor, which we can do by doing that. So we inject the IDB context factory in, and then we can hang on to that context factory in our private variable. All standard stuff. Then we want to create our actual new function. So let's go and create our new function in here, which is going to be employee search. And what we need to do is get out the parameters that are potentially passed into this particular function. So we're going to inspect the query parameters dictionary, and we're going to try and get out of there the relevant arguments that are being passed in. So we're going to pass in potentially a first name, last name, an employee ID, and a department ID. And you could pass in any of these or potentially none of these. So that gets us that out of our query string. After we've got those values teased out into our search variables, we can open our database context or request a database context from the factory. So this gives us a brand new database context for this particular function. And then we can do a little bit of entity framework stuff. So the first thing we're going to do is on the context against the employees, we're going to say where we're finding if any of those parameters are null or empty, or if it's a lowercase version of those in each case. So and we compare that against and find the if the column contains what's been passed in is what we're doing. So for first name in the database, we get the value of that, we change it to lowercase. We then look if that value contains what's been passed into the function, also lowercased, so that we're doing case insensitive searches. So you can find things like if first name contains a, for instance. Yeah, that's what we're trying to do. So that gives us a where clause. And then once we actually get the results of that where clause, what we want to do is project that result into a new object that basically gets out the employee ID, first name, last name, email, and the department ID into a new object that we then return as a list in that employees variable. And armed with that variable, we can then go and fill in the rest of the function, create our function response, set our content type for the response as JSON, and then convert that employees object into a serialized JSON object and write that as the payload body that goes back to the calling client. So that gets us an employee search function. As you can see, we're missing this query parameters dictionary object over here. So this is part of the isolated model, not allowing you to easily tease out elements from the query string. So what we're going to do is come over to our project over here and create a new class called HTTP request extensions. And inside here, I'm just going to paste, so you don't have to suffer my typing, that query parameters dictionary. So let's get rid of some of these warnings that we've got. Okay, so now we've got our extension method, and what we're doing is getting the query parameters out of that and teasing that into a dictionary of string to string, so that it makes it easier for us to find those variables. So It's just a simple extension class to allow us to do that. Let's close that out. So that should now be okay. So let's run this up and see what we've got. Okay, that's up and running. So let's come over to our browser and let's just create a new tab in here, and we can go to localhost 3000 API / employee search, and let's pass it a first name equals Stephen, for instance, and there we go, we get some results back. So we're getting 2 employees, employee 100, employee 128, both with the first name of Stephen, different surnames, etc., etc., different departments. So that shows our API is working and up and running. So that's a good start, but that only gets us so far. So the next part of the problem is if we were in a UI, we might want to show their picture, for instance. So as well as just their details, if we want a profile picture for them. So how can we do that? So let's go and add another function that will get us their profile picture. So we create a new function called employee profile picture, which takes an extra parameter of the employee ID as part of the root. So we get an extra parameter here into this particular method, which is right over here, the ID. So that comes from the actual root that you pass in. And so given that, we can go and get another database context in here, and inside there we want to go and get the actual employee object for where the employee equals the ID that's been passed in. So that's what that's getting us, and we ought to do some error checking if we don't have that. Not found response doesn't exist yet. We'll go and create that in a moment. So we need a byte array to store the actual profile pic from the employee, which is what it's stored as in how it comes back across the entity framework is a byte array. So if the employee's got one, that's where we can store it. And then finally we can start to set up our response as we normally would. So if we've got this far, we're an OK response. The content type we can also pull from the database. So it could be a JPEG, could be a PNG, for instance. And finally we write those bytes that we've got from the image into the response. So that should get us a profile picture, but let's just go and add that not found response into our response extensions. So back over here, response extensions class there, and let's paste it in a not found response, which follows exactly the same idea as all of our other extension classes that we've been adding. We create our response, we set the status, and if it's got a body, which this one never will have, we just send back and formalize that as a JSON payload. So that'll do us for now. So we can close that out. That's now happy. So we should be able to stop and restart this. Okay, that's up and running. So let's come back over here, and instead of employee search, we know an employee is ID is 100, for instance. So we can do employee /100 / profile pic. Was it profile picture? Let's just have a look over here. Employee profile picture. It's 2 capital P's for Peter. Profile picture, and when we fire that in, we get back a profile picture for Peter. So we know that that's all working, so we can search for employees, and given that we know their employee number or ID, we can get a profile picture for them. So that's basically how we can do some more complicated database functionality from an API perspective. So what we can do now is come over to Nuxt, and let's actually go and add a page that's that's going to use some of this functionality just to demonstrate the benefits of what we've been doing. So let's come over, and in the pages, let's create a new page called employee search .vue, and I'm going to paste in the actual template for the page. So what this is doing is defining a search form. So we're using Vuetify again, that we've used elsewhere on our site. And incidentally, if you haven't been following along, then there's some other tutorials on how to create contact pages that use Vuetify and go through some of the other details around here. But we essentially create a Vuetify form that's going to call a submit form method when we actually submit the form. We define a first name and a last name and an employee ID field and a department ID. So these correspond to the search criteria that we can pass into that API function. We've got a number rule, so some validation going on around employee ID to make sure, and department ID to make sure it's numeric. So just some upfront client side validation, nothing too sinister there. And we store the data into a form data first name value, and we also have an errors collection against first name as well, in case any errors occur inside the API or inside our client side validation if we had any. So if number rule, for instance, throws an error, then that's where we could potentially put some errors. So that gets us a form with a submit button that we can call, and then we've got a variable here called employees that we're just outputting the raw detail of. So what we need to do is go and add some scripting into this template. So let's go and put in some boilerplate scripting. We need our layout so that we don't break our layout and look and feel of the rest of our page. And then inside the data method, we'll define everything that's being used by the form. So we've got our form data with first name, last name, and the employees collection that we're showing in the page as our response data. We've also got a couple of flags here that indicate whether the form is valid or not. So on top of the data method, we also need the computed method, where we can do some validation to work out if we need to enable or disable the search button. So this is actually called, if I just scroll back up on the search button here, so it's disabled or is search button disabled. It's basically just checking that you've input some data into one of the fields and returning true if you have. So it enables the search button for us. So that just protects us from calling our API with no search criteria. Then we can add our methods into this, and inside methods, that's why it wasn't formatting. I forgot my script tag. What an idiot. Anyway, so inside our submit form, let's have a usual bit of boilerplate that we've done exactly the same in our contact form. So we set the busy flag to true because we're submitting the form and doing some potentially long running work. We then have a try catch, and if we catch any errors, then we put up our notification toast to say that something went wrong, and we also console log those errors so that we can see what's going on. So inside our try catch, we need to do inside our try, we need to do our usual with cookie consent, now that we've got cookie consent on this site. So we set that. If it's not already been set, then we can create a constant that gives us our URL that we want to call. So employee search with potentially a query string after it. And then we can interrogate all of the input values. So if we've got some input to actually go in, then we can do that. Let's just put the else into that so that you can see. So if we don't have any input, then we pop up just an alert at the moment, an error, to say that you must enter some search criteria. So again, we're protecting our API against the user not actually inputting anything. And then within this block, we can go through each individual field and check if it's got a value, and if it has, then we add in that search criteria with the value from the search form into the actual URL that we're going to call. So that's the one for first name. Let's go and do all the others. So that should give us a populated URL at this point. And then all we've got is a simple call to using Axios to that particular URL using a get call, and that populates the employees collection with the result that it gets back. And finally, we clear out the form so that it's ready for fresh input again. So we save that. And lastly, what we need is obviously a bit of styling. And because we've got our toasts on here, we need some styling that's not scoped just to this, just to move the various different bits and pieces around of Beautify and the actual toast notification. And then within our scoped styling, we just do a little bit of styling on the search form itself, just to make that look a bit better. Now we've got our search page with at the moment an empty collection. So if I go in here and we do our same test that we did earlier and search for Stevens, then we can see that we get exactly that same response coming back from the API. We get two results, one for employee 100 and one for employee 128. But we can go and do any kind of searching now based on whatever we want. So employee 100, for instance, only gets us back employee 100. So it's all working, but we just need to finish off this bottom bit down here so that that looks a bit nicer. If you're finding this useful, then why not hit those like and subscribe buttons so that you get more content as I release it. So let's, now that we can actually see the data, go and replace that with something a little bit nicer. So basically, if the employees has got something in the collection, then we create an iteration. We iterate over the collection for each employee. We pull out their first name, last name, and we also have an image, and the image has a URL that basically to go and get our profile picture from our API. So we're injecting in the employee ID into that URL, and then calling our API to go and get the actual bytes for the image to be displayed. We've got some nice accessibility stuff there around putting in the alternate for the picture using the first name and the last name from the employee as well, and then some various employee details that we pull back from the API. Let's add in a little bit more styling as well around some of that at the bottom, but basically we don't have to change too much functionality, so it's just some simple enough view stuff. And now that that's built, if I come back over here and we do our Stephen test again, then we get our two results with their profile pictures against them and the details against them as well. So let's go and get everyone in department 80, for instance. So we can see that we get back, you know, a bigger result set this time. So we are actually querying a database, getting our data back and showing that data inside of our Jamstack website. So we can do complex search functionality even with the Jamstack. We're not restricted against doing anything with databases or anything like that. So that's pretty much it for this video. We're going to build on this in some future videos, I think, to enhance this a little bit or look at how we can do this a different way. So stay tuned for that one. And thanks for watching, and I will catch you in the next video.